Hey, what's up, everybody? Mark Price here at devslopes.com, and we're going to continue on our quest to learn how to code in Unity 3D with C#. And if you're wondering why my IDE is dark gray, it's because I have activated the paid version of Unity just so I could have the gray IDE, and plus we're going to be releasing our own games pretty soon here. So this is what it looks like. So what we're going to do in this lesson is we're going to learn about conditionals. Okay. In programming, you have to be able to make decisions, make choices in your code. That's how it works. If you don't have code that makes decisions, you don't really have an application. So we're going to talk about that today. So over here in the assets folder, I'm going to right click and go to create C# script. And we're going to call this conditionals. And the reason why I call it conditionals is because based on some condition, you make one choice or another. So what we're going to do is go to assets, open C# project. And it has not synced yet. There we go. Conditionals.cs. Perfect. Double click that. I'm going to use the Alt or Option and scroll wheel to zoom in here a little bit better. Okay, so the idea behind conditionals is that you just basically make a decision on what you want to do. So for instance, let's say we create a variable. So we create, let's say, health. We set it to 100. Okay, we have a variable where health is equal to 100. Now, let's say that we want to show if the game is over or not. How could we do that? Well, if the player's health is less than or equal to 0, then the game should be over. So let's create another variable. This is called a bool, or for boolean. It can be of true or false value. And so we're going to call this is game over equals false. Is the game over? Okay. So let's write our very first condition. If health, okay, is less than or equal to 0, and then we're going to put two curly braces. Now question, why would we put less than or equal to 0? Why not just put 0? And this is a common mistake that new developers might make. You might say if health is equal to 0, but what happens if you have 10 life left, but an enemy takes 20 damage from your health? Okay, well now you're in the negative numbers, and so you have to check and see if it's below 0 as well. So if we're less than or equal to 0, okay, then game over equals true. The game is over. And then, this is really cool, we can say if game over equals true, now we can say debug.log, the game is over. Okay, so if the game over equals true, then let's print the game is over. But what if it's not? What if we want to print something else? Well, we can use an else condition or statement here. And we can say debug.log, you're still alive, buddy. Okay, really interesting. So we use the keyword if, and then within parentheses, this is where the condition is. So we say if is how you start a condition, and then the condition actually takes place in the parentheses. So if whatever is in the parentheses turns out to be true, this will be called, whatever's inside of these curly braces here. If it's false, it will not be called. So in this case here, if game over equals true, it's going to call whatever's in here. But now in this case, we're actually saying else. So if this fails, it's not true, then it's immediately going to go into here. Okay, so whereas up here we only had an if statement, and if it's not true, it just moves on. Here we do one thing or another thing. Okay, really cool. So if we go back to Unity, I'm going to create, actually just here on the main camera, I'll throw on the conditional script. Okay, if you click the main camera here and click the inspector, you can see that the conditional script is down here. And so let's just go ahead and play and see what the console says. Okay, so the console says you're still alive, buddy, as you can see right here. In fact, let's put this console right over here. Oh, let's actually turn off the maximize on play. That's our problem. On the game, I'm going to click game. I'm going to turn off maximize on play. In fact, I'm going to close the game tab altogether. Actually, let's put the game tab on a different window so it stays off the screen, and we'll put the console over here. We got two consoles now. Okay, let's try this again. Click the console, click clear. I'm going to click play. You're still alive, buddy. Why are we still alive? Well, what did the code say? If health is less than or equal to 0, game over is equal to true. Well, the game is not over, so therefore it was never called here. So let's actually put the health here to -10. We just got hit, okay? Let's go back to Unity. Make sure you save. It's always important to save. If you don't save, your code's not going to update. Common rookie mistake, okay? Don't go into Unity without saving. Got it? Don't be a rookie. All right, so let's click clear and play again. The game is over. Dun, 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 dun. Okay. So you're starting to see how how you make decisions in code. And if you could start imagining now your own games, you wouldn't write code that's much different from this. You need to have some type of way of knowing if the game is over or not. Your player probably does have some type of health, and we just made some conditions based on that, which I think is really cool. Okay. What if in our game we want the ability to have more than one life? So we don't want to end the game unless they've died 3 times. Okay, so let's create another variable here called int. We're going to say lives equals 3, so you get 3 lives total. All right, so we only want the game to be over if the health is less than or equal to 0 and if lives equals 0. Okay, so how can we do that? Right now it's just, setting it here with one condition. Should we write another one like this? If lives equals 3, game over? Well, no, we don't want to do that, right? Because we need both conditions. Health has to be less than or equal to 0, and it has to be lives has to be equal to 0. Okay, really interesting, right? So what we could do is we could say if health is less than or equal to 0 and if lives equals 0, then game over is equal to true. Well, is this code going to run right now? Well, or is it going to print true like it did last time, I mean? Well, the answer is no, because lives is equal to 3. So if you use the double ampersand here, okay, you're saying both sides of the condition need to be equal to true in order for this to be called. So we've added an extra condition, and, okay, both need to be equal to true. So if health is less than or equal to 0, and if lives is equal to 0, game over equals true. Well, let's run it. Save it, of course, and run it, and see what happens. You're still alive. Okay, so the game did not end as we had expected it to. And maybe we have a logic error. Maybe this is how it's supposed to be. I mean, it seemed a little strange that it said we're still alive even though we weren't. So, what's interesting here is we might write some better logic. So if game over equals true otherwise, what we can do is we can say lives equals lives minus 1. So we take a life away. Actually, let's not even do that. Let's just look at our lives here and our health and try and get it to be true first. So lives equals 0. Well, we could simply just move this to 0. Okay. I saved it. I'm playing it. The game is over. So it worked this time. Okay, so we've got health, we've got game over, lives. So now we have a double condition here. Pretty cool. We can now make more educated decisions in our code. It doesn't have to be just one condition. It can be multiple conditions, and you can have as many as you want here. It doesn't matter. I mean, it's typical that you won't. If you're writing like 10 different conditions within the same parentheses here, your code is probably not that well written. You could probably break things up a little better, but you can have multiple conditions here. No big deal. What else could we do though? How can we add more complexity to our game logic? Well, let's say we have a timer in the game actually. If you've ever played Clash Royale, okay, not only can you lose the game if you lose, there's multiple ways to lose in the game, right? If you've ever played it, it's on iPhone. It's a fantastic game. If your main tower is destroyed, you lose the game. All right. In fact, we could even do that here. Let's change some things around here. Let's give you a real example of a real game. Okay, so let's say we'll say int towers remaining. Okay, and we're gonna say equals 3. All right, and we'll say Boolean main tower destroyed. If you haven't played the game, you can pause the video, go get it, and play. You'll see what I mean. Main tower destroyed equals false. Okay. And then another one, let's call this a float. And we're going to say timer. Let's say the timer starts at 2 minutes. Well, I was going to say we could do it in milliseconds or whatever, but just for right now, just for fun, we'll say the timer's 200. Okay. Okay, so we got a timer, and we've got, let me put the semicolon here, and we've got towers remaining and the main tower destroyed. Okay, so how can we lose the game? Well, if the timer runs out, okay, so if timer runs out, so what would that be? Is less than or equal to 0. So if timer is less than or equal to 0, how can we lose the game? Well, if main tower destroyed equals true, and we can say, or if towers remaining equals 0. Now this logic's not perfectly matched up with the actual game, but I hope you're seeing the idea of what's going on here. So this is interesting. We created a condition and then another condition with a condition. Can we do that? Yes, that's this common typical programming that you would do. So the first condition, we don't even care if the main towers, at this point we don't care if the main towers are destroyed just for the sake of this example here. So we're saying if the timer is less than or equal to 0, if main tower is destroyed equals true, or if towers remaining equals 0, okay, debug.log, you have lost the game. Okay, so this is interesting. This is the OR statement. Okay, it's the double pipes. It's shift and then the double pipe button, which is typically under the delete key on the far right of your keyboard. So that's OR. So if one side or the other side is true, so one side could be false, but the other side's true, and then this would still be called. Okay, that's the OR sign. But this really isn't the Clash Royale logic. Okay, main tower destroyed. If main tower is ever destroyed, you automatically lose the game. So I'm thinking this actually needs to come out of here. So we're going to say if main tower destroyed equals true. All right. And what we can do here is an else if. That's interesting. So we're saying if main tower is destroyed equals true, we can copy this here, then you have lost the game. Else, so let's say that's false now. This is definitely false, so it's going to try this one now. It's going to say if the timer is less than or equal to 0, okay. Well, if that was false, then it's just going to skip on you and keep playing the game. So if timer is less than or equal to 0, towers remaining equals 0. Well, that's not the right logic either. Oh, that's interesting. So this should probably be player 1 towers remaining and int player 2 towers remaining. Oh, this is interesting. Okay. Well, then we're going to need another Boolean here, right? So we'll say player 1 main tower destroyed. We'll copy this here. We're going to say player 2 main tower destroyed. All right. Well, let's separate these here just to make it look prettier. Okay, so now we're tracking multiple things here. Player 1's remaining towers, player 2's remaining towers. Okay, this is really cool. In fact, we don't even need these to be on 3s anymore, right? Because we know that the main tower, if it's destroyed, we lose the game. So we really only need to track the other 2 towers. Even though there's 3 total, we only need to track 2. Okay, player 1 main tower destroyed, player 2 main tower destroyed. False and false, and the timer's the same. All right, this is getting really interesting now. Okay, so what we can do here is we can say, in fact, let's just delete this code here and refactor. We're refactoring our code, making it better, writing some better logic. So if player 1 main tower is destroyed, or if player 2 main tower is destroyed, okay, we're going to say debug.log game has ended. Dun, da, da, da. Actually, that kind of sounded like the Clash Royale sound. And then, okay, so then we'll say else if. And what was our else if? Okay, so else if our timer else if our timer is less than or equal to 200, not 200, 0. So if our timer is counted down below 0 or equal to 0, that means the game is over. Okay, so the game's definitely over. But who won, right? And we didn't even check who won over here. That's really interesting too. So what we could do is we can make this code better first. We can say if player 1 main tower is destroyed. Interesting. Why didn't I say equals true this time? And I didn't do it here, and I didn't do it here. Well, that's because this is a Boolean, and a Boolean can only be true or false. What we're basically doing is saying, hey, is this one true or false? Or is this one true or false? And it's the same thing as if I said equals true. Okay? But why write the extra code? It's the exact same thing. It's going to be true or false because it's a Boolean. So if player 1 main tower is destroyed, what could we do? Well, we could say debug.log player 2 wins. Okay? Else, we don't need to do an else if because we already know that one of these 2 towers was destroyed. So if it wasn't this one, then it clearly was the other one. So we can just say else player 1 wins. Pretty cool, right? Same thing here, right? We could say, so the timer is less than or equal to 0. Now we need to figure out who won. Okay? How do we do that? Well, whoever had the most towers destroyed of the other player wins. Okay? So we can say if player 1 tower remaining is less than player 2 towers remaining. So if player 1 has less towers than player 2 when the timer ran out, okay, that means player 2 won, right? So debug.log player 2 wins. Okay. Can we just do an else here to say, okay, if not, the other player won? Well, no. And why? It's because what if a player ties? Oh, snap. Yeah, we need to account for that too. So now we can say else if player 2 towers remaining is greater than player... Oops. That's not wrong. Less than. If player 2 towers remaining is less than player 1 tower... Let's just copy this. Make it easier. Okay, so if player 2 towers remaining is less than player 1 towers remaining, it means player 1 won this time. So debug.log player 1 wins. Yay! Now, let me add the quotes here. Now we can do the else statement. So if player 1 didn't win when the timer ran out, and if player 2 didn't win, like the towers were the one was not greater than the other, then what happened? It was a tie. Now we can say else. Okay. We'll say debug.log the game was a draw. Okay. So look at that. That's pretty cool. We're starting to use if and else statements, conditional statements, and conditional checks to see how our game's going to operate. And this is how you start building games. You start using logic. Okay, you're probably starting to think of all kinds of games now that you can do with this logic here. We use the or the double pipes to say one or the other is equal to true, then go into the condition. We also use the double ampersands like so. That means both of them needed to be true in order for the condition to be to go into the statements here. Okay. Talked about less than or equal to. We've talked about less than. You can also do greater than. Okay, you can use some of these simple symbols here to do immense amounts of logic. And just for one more demonstration here, which is not necessarily related to games, but the important thing that you need to understand is that conditionals basically are always true or false. So you can actually do strange things like this. If true is equal to false, or if false is not equal to, that's a new one, right? So if false is not equal to true, remember there's equal to, which is the double equal sign, and then there's not equal to, which is the opposite of that. Okay, it's a new symbol here you're learning. Okay, these are called operators. Particularly, they're called binary operators. And what a binary operator does is it works an operation on the left and it works an operation on the right. So these are binary operators. This is a binary operator. This is a binary operator. So if false is not equal to true, okay, and if 1 is equal to 1. Does this look like crazy stuff? I forgot the double ampersand here. What do you think? What do you think is going to print out here? What I want you to do is I want you to pause the video and actually let's do this. Debug.log. Did we get here? What I want you to do is pause the video. Don't run your code, but I want you in your mind to figure out if this code is going to run. Are we going to see this run? Okay, pause it and let me know what you think. Does it run or not? Well, let's see. So if true is equal to false, well, we know that's not true, so that's false. Or, luckily we have an or. Or if false is not equal to true, that is true. So false is definitely not equal to true, therefore it's true. And if 1 is equal to 1, okay, interesting. So that's true as well too. So if this or if this, okay, well this is looking pretty good to me. I think it's gonna run. Let's see. Let's run it and see, did we get here? If I play it, did we get here is definitely called. Okay, so does it make sense to you? It ran this operation, it was false, but luckily we had an or, so it's then, okay, is false not equal to true? Well, false is not equal to true, therefore it's true. And if 1 equals to 1, which is true. You could also use order of operations as well by using parentheses like so to do certain sides of the operations first if you wanted. In our case, it didn't matter. So you've learned a lot here. We've worked with if and else statements, else if statements. We've worked with the or, the double pipes, the and. Those are binary operators or conditional operators as we like to call them. And then we wrote some simple game logic based on this. And this is the foundation of everything you're going to be doing. You're making decisions in your code, and that's how games live. So I want you to go play your favorite game or any game that's nearby on your phone or whatever. And I want you to play it, and then I want you to stop and think, what kind of condition just happened? Okay, think any game you could think of. Let's say, what's a popular game like Clash of Clans, for instance, instead of Clash Royale. If I press this button to, if I press the little hut to get coins, okay. So if the user press the hut to get coins, then award the player coins and start the coin animation. Okay, are you starting to see how these things work? You make decisions in your code, and that's how it affects the player of your games. Really cool stuff. I think we'll call this video done. You've learned a lot, very foundational stuff, and we'll move on and forward. Mark Price at devslopes.com. See you next time.